Hi, I'm Tristan Zimmer.
Hi, I'm Connor Radius.
Hi, I'm Xavier Garcia.
Hi, I'm Connor Thompson.
Hey, I'm Ryan Sanchez.
I'm Brandon Spoyan.
I'm Trizon Jimerson.
And we're the Blue Power Rangers. All right. I want you guys to take one moment to yourselves and just use your imagination. I want you guys to imagine the sleekest, fastest, most intimidating vehicle that your thoughts could ever possibly put to motion. Now, do you guys think of a vehicle that looks like one of these? Kind of a little strange, got a little bit of some odd design qualities to them. They don't honestly look very fast, do they? I wouldn't say any of these cars are the ones that I would have thought of, per se. I would have thought of something a lot more along the lines of these F1 Formula One cars. The single seat, lightweight design, and aerodynamic properties of F1 instill a sense of awe in any person who sees one. If you've been lucky enough to see one in action, you and everyone around you knows that these cars are insanely fast. However, the average person would likely never be able to afford one of these F1 cars on their own, as going into the store and purchasing one would run you about $10.5 million. Now, what is the next best thing to owning your own full-size F1 car? If you said having a remote control version of one made with parts that you created, then you've got the right idea. Prior to now, making all the parts necessary for creating your own remote control car would require purchasing thousands of dollars of machinery and parts. A more recently viable alternative to this is to 3D print your own parts and assemble it yourself. You might ask, but aren't 3D printers absurdly expensive? The answer to this is no, due to the popularization and increased production of 3D printers. As the technology has advanced and become more widespread, it has also become much more cheaper. Instead of having to spend thousands of dollars on a machine, consumers can now purchase good quality printers for under $300. If you are one of the many people who have taken advantage of the ever-increasing affordability of this technology, you can utilize our product to create your own F1 car from the ground up without breaking your bank account. So what is our product? Our product is a compilation of files that can be downloaded and used in conjunction with a 3D printer in order to create the chassis of a remote control vehicle that resembles an F1 car. The unique aspect about our product is that it allows the consumer to create something physical without purchasing a ton of physical parts. Once our files have been purchased, we will additionally send you a package including the screws and bearings necessary to complete the body. The only thing a creator needs to do is then print them, and they have the functioning body of a car that they can purchase electronics for and build for themselves. So as you can see, we have a picture of a 3D printer on this slide. This is the Creality Ender 3, which is a very popular consumer printer. It is one of the most popular actually because it is you can purchase it for under $300. And this printer prints quality prints that resemble that of a printer that would cost you thousands of dollars. So our product is not something that is going to break your bank account. In fact, many people have already taken advantage of this technology and they already use 3D printing for their own benefit, and it's not necessarily something that you have to go out and buy. You might already have one of these.
Hi. So as we all know, teamwork is crucial for any group project. And with COVID, that adds a whole new dynamic. I don't know about any of y'all, but I didn't know anyone in my group before I met them. But despite that fact, we all came together and we worked hard. And I found out that they're a great group of guys. And we all work really well together and we're able to successfully get this project done, despite the global pandemic happening around us. So we were able to first meet at Tin Can Alley, and we were able to drink coffee and talk about the project and figure out what we were going to do and the timeline we'd get it done. And then we continued to meet every week on Discord, sometimes in Google Meets, and sometimes at Ryan's house because he was generous enough to let us stay there during the project. Well, not stay there, but and so we continue to work hard, and we found that this worked out very well. And what we did was we divided the project into sub-assemblies that we would then give to multiple members of the group. And these sub-assemblies had 2 to 3 people working on them, and they all worked together, making sure their parts aligned and everything went together. And then we all worked together as a group to make sure that it all went together and all the screws, all the holes, and all the pieces matched up right so this project could come together. Now, just like any project, we had our own issues. We found that transitioning between 2020 SOLIDWORKS and 2019 SOLIDWORKS provided a great amount of issues. So what we did was we just had everyone compile their files onto one computer, and then we all worked together, getting the assembly set up and getting it all done. And this is a picture of our group at our group meeting, Tin Can Alley, and then a picture during one of our meetings on Discord.
So, starting from the bottom, this is where our project originated from. It originated from one of our group members' past projects. He designed and built a toy car, which was a very rough creation with many problems, such as the parts didn't fit well together, he didn't have a steering system, there wasn't enough clearance in the wheel wells to permit the axles to turn, and the overall product didn't look too good, as you can see in the picture. This is why we modeled our project after an F1 car. Despite the complexity and immense detail that goes into an F1 car, our project is rather simplistic. For the purpose of this project, however, we kept the body of the car. Even though it's a Formula One car, it's mainly for aesthetics. And for the functionality of the car, we mainly focused on getting it to turn and create a steering system, because on the past project, it didn't have one and it didn't turn too well. And this is what we came up with for a rough sketch. So in the beginning of the project, for our F1 car, this is what we wanted to base it off of. As you can see in the following slides, you'll see what we kept and what we removed based on our final project.
Okay, so basically our project kind of started with this crappy idea that we're trying to revise and remodel. And so we came to this rough sketch, and obviously it doesn't look too well, but eventually we got to this 3D assembly. So we have a lot of problems with this, and obviously it took a lot of work. We had to get every single person in this group working together on this, getting all of their assemblies and their parts in. And the hardest part was we had to get the models onto one computer and the drawing. And so to do that, you know, we had to email each other and go to each other's computers and meet up with each other. It was a lot of work. And especially like keeping in mind that we had to keep a project idea at hand. So basically we had to do this with the constraints of the project, keeping the inside of the body hollow, making sure the steering, the wheels can turn and the car can function and properly work with all of the given electronics.
All right, so for our parts list, we have 3 different assemblies. We have a steering system, the body, and the back end. It took a lot of collaboration for these to fit well together. So for our steering system, we have the rack and pinion assembly and the wheel assembly. So we had to make sure that those 2 people collaborated so that those would fit well together. For the body, we have the base, some hardware, the nose, front cover, back cover, left and right body panels, mid body, and the wing. So that one's all throughout the car. 3 people split up this assignment. And then the last one, we have the back end with the rear axle holder, and then the wheel assembly again. So really just bring the whole car together with all these assemblies. And this is how we broke up the work for the groups.
All right, for the first system is the steering system. This is one of the most important systems for the car because this was the main problem that we wanted to fix. So we really took our time on this project, made sure that everybody was like knew what was going on and making sure that every part would fit together correctly. So I designed the rack and pinion system, which we all agreed upon because it's one of the easiest systems to make and one of the easiest to connect a servo to. With the connection to the nose, we had to make sure that the holes aligned correctly. So I had to talk to Ryan to make sure that all the tolerances were right and everything was correct. And as well, I had to talk to Trezon about the tires and make sure the holes for the hubcaps would be able to fit and make sure that the wheels would be able to spin freely. And then for the design of the nose, we made sure that it was a little more sleek and more fitting to the car and made sure that it had a lot of downforce so that it would be a little bit better weight distribution on the car. And we made sure the rims of our vehicle originally had thicker spokes, which we slimmed down in order to make the car more aesthetically pleasing and again, lower the amount of plastic required to create the actual car. For the actual car, we have a little part that you could probably see all the way at the end at the bottom right. That is the thing that connects to the servo between the wires that will allow the steering system to push forward and back, which will turn it left and right, depending on if it goes forward or backwards. And you could easily do this by programming your own stuff and making sure that the servo is able to move back and forth. And that's pretty much basically how the steering system works and how the front system all fits together.
Okay, so now this is the mid-body assembly that me and Tristan worked on. So we had a lot of problems with this. Originally, we had like an intake halo that we eventually had to take out. And we also had to redesign the walls for the right body and left body pieces so that they were a little more easier to be printable and stuff like that. I think the hardest part of this was making sure all the parts fit together flush and kind of mated with each other. Then after that, we could throw in some screws to make sure that it all came together properly and worked.
Yeah, so I worked on the top pieces, and so what we did was after the front and two side body pieces were made, I created the top two plates, and I made them so they had slots that aligned perfectly into the side pieces, and I connected screws through all of the pieces so they'd all connect, and I created it so on the bottom of the front top plate, there's actually a hole for the screw head to go through the front piece. And then even though we took out the intake halo, we still had a curve down the back, and we followed the body of a Formula One car, so it would still maintain its aerodynamics and still have the sleek design that we all like.
All right. So design process for the base and wing. We have a front base plate, a back base plate, and then a rear wing. The way this works is they connect with a female and male fitting. And then there's screws all along the sides and the back so that we can fit the other pieces to it, like the wing, the side panels, and then the front steering system. We really had to come in collaboration with this, and we used all the same screws for it so that it would make the building process easy.
So for the rear wing design, it was inspired by a typical Formula One car rear wing, and we chose that because it allows extra downforce on the back side of the car, which increases traction and pushes the rear wheels to the ground, which prevents lift on the car.
All right, so in this exploded view, you can see that there's two different parts for the base. So we have that front part, which would connect to the steering system. You can see the hole at the bottom where the rear base would fit into it. And a big part for the base is, and the reason why we split it up is because we wanted the printing process to be easier. Because if it's split up, most of the time on 3D printers, the base plate's not big enough to fit both those pieces in one take. So we split it up like that. And then we had to make sure it was sturdy enough so that it could take high impact from roads and stuff like that, so that the whole car would still fit together.
All right, so we decided on making the rear end of the car so that it has a lot of space for the motors and gears that would be able to power the axle if you wanted to put those in. And we made the rear axle a press fit into the bearings so that it wouldn't slide around or move around in the back of the car. And to make the car more efficient, the main weight of the car is distributed towards the back, which would allow more torque so that the wheels have more power, which overall increases the speed of the car and makes the acceleration faster.
And for the design of the wheel, as you can see on the left-hand side of the slide, the general purpose of it is just to keep it simple, which is by having less material, which is what we did with the less spokes, and also being able to mount it to the rear axles and the hubs. So as the design, I said we use less spokes, which reduces the amount of printing material needed, and it keeps it lightweight, but also the design of the 6 spokes keeps it sturdy. Also, you have the tire and the wheel, the bolts and stuff that mount it to the axle and the hub.
And then this is the rear assembly of the car, as you can see, with the 2 bearings, the axle, the wheel assemblies, and the rear axle holder. And then this is the full assembly, exploded view of the car with the front and rear wheel assemblies, the base assembly with the rear wing, and the mid-body assembly with all of the screws in the